right, I guess that's my cue to start off. Hello, everybody. Really excited to be here. I'm sure you'll be tired of hearing speakers say, "Well, this is my first event since COVID," or so finally to be outside speaking to something else than a webcam or a laptop. But I can't help myself. So it's really exciting to finally get outside and do a live event. It's been a while already. I was here last time, which I believe is 2 years ago. Really fun conference. I love TechBBQ. And of course, hopefully the people online are enjoying it as well. All right, we're going to be talking about how to use AI/ML for startups. About me. My name is Anton. I work for AWS. I'm a startup solutions architect. I've been working for AWS for about 3 years now. I focus on AI/ML and fintech startups in the Nordics and the Baltics. Before joining AWS, I had my own startups, so I'm a former founder, but also former engineer, software engineer. So have both experience, hands-on experience developing stuff and building startups, as well as advising them right now in my current role. As you can imagine, I speak to a lot of startups. Really exciting to hear all the ideas and hear about what people are building in the Nordics and the Baltics as well. Cool. So for today, I want you basically to remember two things. Like if you're a startup or maybe you're thinking of building a project, there's two things I want you to remember after this presentation. One is the rice cooker. Two, the fighter jet. And we'll get to them, of course. But first, a little bit of terminology, right? So I don't know how experienced people here are with machine learning or how technical the audience is. But just to cover our grounds and make sure everybody's on the same page as we go through the presentation to the best practices, let me cover a few topics. First, let's talk about deterministic and stochastic systems, right? A deterministic system is a system that will have the same output as long as you don't change the input. So this can be a set of rules. If light sensor doesn't get any light, we'll turn on the light switch, right? It's a pretty deterministic system. There's no randomness involved. Once you deviate from that concept, once you add some randomness to the system, you're then talking about stochastic systems, which are more complex, right? Then you've probably seen this slide already. Let's see if this actually shows here. All right, seen this slide, but just to make sure we got this covered in the audience. By the way, I should have asked in the beginning, maybe, who here considers themselves to be a technical founder or just a technical person? Can you 1, 2, 50, let's call it 60%. 60%, all right. So I'll still recap to for good measure, right? No presentation is complete without a Venn diagram, so there we go. So to summarize, we have a number of ways to do ML. At the very outer layer, we can call the algorithms artificial intelligence. This can be as simple as an if-else logic. So it's simply a task that requires some thinking like a human would think about, right? So again, a light switch, which looks at whether a light is on or off, can be considered AI. It's a very simple rule-based algorithm, but it's still AI. Then once we go deeper to more sophisticated systems, there's machine learning, the yellow circle, which is then a bit more sophisticated, where you would take some input data, and you would typically you would feed that system input data and the results you want to get, your labeled data set and what columns you want to predict, plus the your data, and it would output an algorithm, right? These are your, for example, linear regression systems, for example, or linear regression algorithms. And finally, the most sophisticated, or the more sophisticated subset of algorithms from inside machine learning would be deep learning, where we use neural networks. The technical guys will be sick of seeing these slides. I'll quickly cover them. Neural network is algorithm that was inspired by how the human brain works, or the brain works in general, where you have several neurons that excite or don't excite serve other neurons in downstream. So you would have your input layer with a number of neurons, and they would propagate and excite more neurons in later layers, and your final layer will be your output. Now, this seems very simple, right? But once you put enough parameters and enough layers in the system, just to give you an example, this is GP2, actually already an outdated algorithm. There's already newer models, which has hundreds of millions of parameters and dozens of layers. You can then feed it input like, who is the founder of Facebook? And this neural network will tell you it's Mark Zuckerberg. Now, mind you, that system doesn't have a rule that somebody programmed to say, like, if somebody asks something about Facebook and founder in the name, then tell Mark Zuckerberg. No, this system has been trained on a large body of text taken from the internet. All right, finally, let's talk about the rice cookers. So how does a simple rice cooker work? So a rice cooker, you put rice and water in it. You put it in a vessel that has a heating or a temperature element at the bottom. Then there's a heating element that will start to heat up the water and the rice mixture. It will start to heat up until the water evaporates. As the water has completely evaporated, and the temperature that the sensor is reading will go above 100 degrees Celsius, because the maximum temperature of water is 100 degrees Celsius before it evaporates. And when the temperature sensor is reading above 100 degrees, you know your rice is cooked because there's no more water and the system can shut down, right? It's a simple deterministic system that can be represented as this kind of a tree, right? Pretty straightforward, and gets the job done. Now, if you read Reddit or cooking forums for rice cooking advice, you'll find many people, rice aficionados, advise more sophisticated systems. Like, for example, this rice cooker you can find on Amazon, and mind the fuzzy logic label in there, right? So that's what makes it expensive. There's a computer in this rice cooker. It's no longer a simple deterministic system like we've seen previously. The simple decision tree is something a bit more complex. And the way fuzzy logic rice cooker works, it no longer works with binary logic. The logic is, or it works with fuzzy sets, which means that an element can has gradations of belonging to a set. So you no longer have rice is done or not done. You can have gradations in this. And also this rice cooker has more temperature sensors. So that rice cooker is more performant, but it's more complex. There's more data. It's harder to explain what's happening just because how fuzzy logic controllers are implemented. And this makes it a more complex, even though more performant system. And what I do see often in practice when talking to startups, companies trying to adopt AI, and this happens with me, with my colleagues. We traded some really interesting stories I'll talk about right away, where even from companies like big companies like I'll talk about to small startups, they end up over-engineering, right? So many startups are set out to build this fuzzy logic rice cooker when a simple one would have been plenty. So beware of over-engineering. I'll tell you a story. This story, by the way, you can check it out yourself. This was actually told by a member of the engineering team from Rovio, makers of Angry Birds. They're running on AWS. So Rovio wanted to optimize the conversion rate for their ads. So when you're playing Angry Birds or some other game, you will get ads somewhere on your mobile app, right, for other Rovio games. And the goal here was to based on some input metrics, like you see a player profile. These are your inputs, right? Hours spent last month, which country is the user from, device type, which source game is the ad showing on, the ad zone, to predict which ads would have the highest conversion rate, right? So you can optimize your ad spending, quote unquote. First try, they did try neural networks, right? I'm sure there were engineers who had a lot of fun doing it and spin up expensive GPU accelerated instances, which AWS has, and you can do these things on. But then eventually they find out that doing a more simple, straightforward method like random forests, which is not just simpler to train and cheaper to do inference on, cheaper to run in production. It also outperformed this deep learning system that they spent, I think it was a couple of weeks experimenting with building. And mind you, the random forest is called random forest because there's a number of trees in them, and trees meaning decision trees, and decision trees are not too different from our rice cooker logic, where you can program with if this, then do that. Story number one. Another story from the Nordics too. This is a Finnish website, a Finnish news portal, I guess you could call it. And what they wanted to do, common ask, is to increase the conversion rates for clicks, right? So you want to optimize time spent on their site, reading articles, reading news, and in general, just keep the audience engaged, right? Of course, if you Google this, you'll find plenty of suggestions for recommender systems. I've done a workshop myself implementing factorization machines. It was really fun, some theory there. But in the end, after A/B testing a whole bunch of these sophisticated methods, they went with simple SQL queries where you order the articles based on the number of views that it received now or like a very short time frame, order them last 24 hours and last week and recommend those. Just it's as simple as recommend the most popular, and that ended up outperforming the more sophisticated recommender systems. All right, so two stories that where they set out using systems that are maybe on the over-engineering end, all right? All right, so in practice, what do you do? Well, when you're building, planning to use AI ML for your startup, ask yourself the rice cooker questions. Those are the questions to make sure that you're not over-engineering things. Question number one is, how large is your data set, right? There's a rule of thumb that the amount of data you have should be proportional to the number of degrees of freedom that your model has. So if you have only linear regressions with a handful of parameters, right, you have less degrees of freedom, you can afford to train your model on less data. There's some numbers thrown around, like 10 is a number that's been thrown around, but the bottom line is, the simpler your system, the less data you need to have, right? So if you don't have a lot of data, stick to the simpler systems like decision trees, of course, simple rule-based algorithms, or naive Bayes classifiers, linear regression. And there's a few other techniques that I'll address later on. Second rice cooker question is, did you calculate your baseline? And this is an important one because the baseline for a problem, ML problem, is a performance you get if you implement something simple. And if I'm talking to a startup and ask, okay, so how does your solution perform versus your baseline? And they say, well, we don't have that measurement. Then there's a high chance they didn't try any simple solutions, right? So essentially, having a baseline means having tried something simple, a quick and dirty hack, the most simple thing you can think of, just to set a baseline for your algorithm. And the final, third rice cooker question is, have you tried pre-trained models and have you tried managed services, right? Coming back to the amount of data, I'll tell you a story of a customer of ours. They're in the hospitality industry, and you can book hotels there online. And they wanted to design an algorithm that would show a nice thumbnail for the property, and the pictures for these thumbnails would be uploaded by their customers, right? So I would visit some hotel, I would take pictures. They wanted to train a neural network to pick the nicest looking pictures, right? They ended up using transfer learning, which already uses an existing neural network that's been trained on millions of images, and they kind of augmented that system with their pictures of hotels of properties, hotels that they thought were nice. And they got away with, I don't remember the exact number, but it's orders of magnitude less than millions. Don't keep me to it. I think it's around the 10,000 images, maybe 5,000 images, order of magnitude, which is doable, you know. All right, your rice cooker questions. Let's quickly take a detour to the machine learning lifecycle, machine learning loop. We start out with a KPI, problem statement, okay? And we'll need this before we address the fighter jet questions, because it's a bit more complex. So this first step is aligning your stakeholders, your business stakeholders, defining a KPI. So let's say if you're maybe you're a truck manufacturer, your KPI could be the amount of time, and you want to do predictive maintenance, right? So you could define KPIs like the amount of money spent by idle truck drivers because their truck breaks down and it wasn't repaired, or maybe the amount of money it costs to send out a repair team versus preemptively repairing the truck when it's in the garage, something like that, right? Business metric. Or if you're doing CC fraud, credit card fraud, it's going to be as simple as monetary value of your detected transactions per month or something like that. Started with the KPI metrics. Then the stage where most teams like to spend their time is the POC stage. This is the time where you can experiment, quick and dirty. You don't need to build too much guardrails, not too much fluff. You just try things out and see if there's a viable way forward, a viable solution that you think you'll be able to implement with a certain algorithms. This is time to experiment, try things. Then there's the hard part, which is actually going from POC to an actual MVP, an actual product, where you need to now think about your data pipeline. How do you ingest your data? Maybe you're using GDPR data, the horror. Then you need to be able to be GDPR compliant. You'll need to have things in place for data lineage, see where it comes from, all these things. Data pipeline, train your models. Now, you'll want to have some system in place that can deploy compute resources to train your models iteratively with some kind of versioning control, etc., etc. Finally, model testing, of course, which your training data and validation data sets. And the last step is productization and launch, of course. And not to forget, we close the loop by measuring and looping back to the KPIs that we define in the beginning with the business stakeholders to set the right expectations and see how our model performs. All right. So again, this is one of those slides like the Venn diagram. No good ML presentation is complete without a machine learning pipeline. But I wanted to cover this because now it's time to talk about the fighter jet. Okay, so in the 60s, there was a colonel called Boyd, John Boyd, and he was a former fighter jet pilot himself, actually. And he was tasked with looking at or investigating, evaluating the dogfights between the MiG-15 and the F-86 fighter jets in the Vietnam and the Korean Wars, right? So the MiG-15 Soviet-made, F-86 US-made. And there was something funny going on there because they noticed that even though on paper the MiG-15 had superior characteristics, that the F-86 was preferred by pilots, and also it won more dogfights, right? So he looked at that. And his conclusion was that the F-86 was preferred by pilots and won more dogfights because there was a characteristic of the system, aside from top speed and maneuverability, the maneuverability, I'm going to asterisk that wasn't looked at, which was the speed of iteration. So Boyd's conclusion was that because fighter jet pilots in the F-86 fighter jet had access to a hydraulic stick, actually, versus a mechanical stick on the MiG-15, they were able to execute their decisions faster and therefore win more dogfights and be preferred by pilots. All right. So John Boyd's law of iteration says that speed of iteration beats the quality of iteration. And he formalized this actually in a system. He defined different steps in that system, and this stuff is actually applied to businesses and kind of things that you see in business schools, for example. There's different steps. First, there's the observe step, where you look at the environment around you. Then there's orient, where you evaluate what you observed, based maybe on experience, cultural background, things like that, right? This can be applied to business or fighter jets. Decide, where you make a decision based on your observation or on your orientation, and then you act. And because any of those things can be reevaluated and be outdated by the time you do them, he called it a loop. So there's a thing called the OODA loop. It's a John Boyd's OODA loop, which is a thing for military strategists, for business schools, and et cetera, et cetera. And this fits very nicely with the narrative that we have for machine learning models, right? So you want to have systems in place that allow you to iterate quickly in your OODA loop, right? So observe, we can kind of shoehorn some concepts here, but it's really very analogous, right? When you observe things, you need to know what to observe. You need to set your KPIs. You need to measure your KPIs. If you don't have them, then what are you observing? Orient. The same thing, right? What do you compare it to? We talked about baseline, for example, right? Act, obviously, or decide, excuse me. Those first OOD are kind of all within the evaluation of your model, right? So how is it performing? Is there any drift? How do the KPIs perform? And the most important one, act also, how quickly can you make changes and how do you measure the changes, right? And all those things should be considered when thinking about the fighter jet questions. First fighter jet question is, what CI/CD tools do you use? So for CI/CD is more of software engineering term, I suppose, than necessarily data science. But CI/CD stands for continuous integration, continuous deployment, which means that if I change something in my business logic, I want it to be integrated in the overall system automatically, tested, and deployed to production with minimal human input. Typically, we put like a message to Slack or something like that, and then somebody has a manual check of it. But ideally, you want to automate it. So for machine learning, of course, there's purpose-built systems. There's on AWS, you can use services like SageMaker and SageMaker pipelines, which I'll talk about briefly later. There's also open source frameworks, so maybe something like Kubeflow, MLflow, Airflow. You can also use step functions, AWS step functions. That's a process orchestration tool on AWS. All those things allow you to orchestrate your deployment and iteration, right? Second FireJet question is, how do you handle model drift, right? For instance, I was working with a fintech that was working on their fraud detection system, right? So they noticed, of course, and it's not that crazy to think of, that fraudsters, once they figured out kind of how the current fraud detection rules work, they changed the ways it work, right? So maybe if you do something simple like really basic, of course, but if you use the same email address when you sign up for something and you commit loan fraud or something like that, it can be as easily as checking for common email addresses. And so as your inputs change and your real life processes on which you measure somehow change, you can get model drift, right? There's different types of drift, data drift, concept drift, but you need something in place to measure it so you can properly evaluate your business metric and evaluate your model performance, right? And have a OODA loop that is quick. And the final FireJet question is, of course, tracking your KPIs. I mentioned this already earlier. This is easy to skip because you do need to involve business stakeholders. If this would be a company, then you need to set the right expectations, right? So if you just set out with a budget without a goal, then it's easy for the business stakeholders to be disillusioned and wondering where is the progress going towards. And here you need to align with stakeholders, define your KPIs, and pick a realistic goal to work towards, where baseline comes in mind. All right. So these are the three FireJet questions to complement the rice cooker questions. And now let's talking about kind of the do's and the don'ts mostly. Let's have a look at a couple of success stories, right? So these days, you no longer need a team of only PhDs to do AI/ML. We can talk about AI/ML startups in roughly three buckets. We have the AI core startups, where these are your startups that are truly started with AI/ML experts, PhDs in the team, and AI is at the core of their business, as the name suggests. Then there's the AI product startup, where AI/ML might not necessarily be the core of their business, but it's an important part. And this will be clearer when I go through some examples. And finally, there's AI service startups, where a startup might use a AI service to give added value to their end user, and we'll also see at one example. All right, AI core. There's this is I guess what our neighboring countries would be a fair evaluation. Holland, Amsterdam. This is an Amsterdam startup, LaLaLand, and what LaLaLand did is they addressed the kind of the market of model photography for outlet stores and online e-commerce for clothing, for apparel, right? Where the websites, e-commerce stores would be spending billions on getting the right models, getting them to photo shoot, and then everything that goes around with it, from renting space to makeup artists, etc., etc. And they automated that, and they created a virtual model that you as a startup, you as a business can use to show your customers how your clothes, the apparel will look like. And the nice thing here is that the customers can then tweak their model based on their appearance, typically. Like then, because these are generated to some degree, these models, you can choose the ethnicity, age, the size, the body type of the model. If you go to their website, you'll see exactly what you would expect from such a startup: a photo and with some sliders and buttons that you can tweak, and that generates diverse models so that I, as a user who's shopping, can look at the clothes and on a person that looks like me. And what this did for their customers is this, as you can imagine, increased the conversion rate, click-through rates, decreased the production costs of their catalog production, right? So because they just don't need to hire as much photographers and models and rent studios. And decreased the cost as well, and lowered the time to create these models, right? So awesome startup. This is AI core, so they're truly the core business value of their product is in AI. Let's look at another one. This is Fishbrain. And Fishbrain can be called a social network for fishermen. So you can connect with other fishermen. You can post the fish you caught. You can tell something where you caught it. And as you can imagine, the Fishbrain team thought of ways to monetize their product. So the base version is free, but then they have a premium feature called, I think it's called Bite Time, that predicts where a certain type of fish is likely to be if you want to go fishing in a certain place. For this, they actually didn't recruit PhDs or machine learning experts. They actually approached one of our partners from the AWS partner network called Module AI, that then worked with Fishbrain to create a model to predict which type of fish is more likely to be caught in which circumstances. So they used actually a relational database where the columns, they started off with the fish family, or like the fish species, weight, length of the fish, and then they augmented that data with things like geolocation of where the fish was caught, the weather, things like that. And the turnaround was pretty fast. I believe that in a few weeks they already had a working model that would predict where fishermen can go to catch the type of fish they're looking to catch. So that's an example of an AI product startup, right? And then finally, let's have a look at an AI service startup. So Deliveroo, maybe some of you have used it, started in London, decided to disrupt the food delivery service. Very similar to, of course, Foodora or Uber Eats, all these apps. So you would start with ordering your food at the restaurant, and it would arrive home. And what Foodora team discovered is that if you get your food delivered in a not in an unperfect state, for example, a drink that has been spilled in the packaging or something like that, that the customers preferred to, instead of chatting with somebody, to just take a picture of the packaging, of the spill, and send it right away to the customer support team for review. Now, what happened is that I don't know, maybe you could predict or you could not predict, but some customers ended up sending very inappropriate pictures, right? Such as humanity, I suppose. And the Deliveroo team wanted to automate the process of filtering out inappropriate images and only keep the images relevant for the support service team. And for that, they used one of our services, recognition, Amazon Recognition, that allows you to easily detect images. There's several features like facial recognition, emotion, sentiment analysis on faces, inappropriate images detection. You can also upload custom labels if you want to use it for something more custom than just object detection. And this worked quite well. So interestingly enough, around 2% of images were inappropriate, and the system worked well, helping their customer support agents to have to deal with more relevant things, right? So that's an example of an AI service, right? Now, all the startups I talked about were built on AWS, right? So whether you're an AI core startup or a AI service or an AI product startup, we have a number of features and services to help you build your solution with AWS, right? Maybe let's start with a startup like LaLaLand, right? An AI core startup. This is where they have machine learning experts that want to tweak their algorithms, that maybe want to develop their own frameworks for CI/CD purposes, right? For model lineage, things like that, data lineage, and they want to tweak the type of instances they're using. They're going to be using some of our more lower level building blocks, like our GPU accelerated instances. We also have FPGAs. If you use that, we have some pre-built AMIs with often used frameworks like PyTorch, MXNet, etc., that are already tuned for the EC2 instances on AWS. So if you're somewhere like LaLaLand, you'll probably be spending more time with these services. Now, for a startup like Fishbrain, that maybe didn't necessarily want to get their hands all the way dirty, but still want to use their own data, maybe use their own models, maybe use some off-the-shelf models, but want to have more control over their models and their algorithms without having to reinvent the wheel on how to deploy models to production, how to manage this production or orchestrate the production, how to track who did what experiments, who did use what data sets to build what models, to train your models on clusters and automatically tearing them down when they're done training, so you don't have GPU instances running unused. For those kind of startups and those kind of scenarios, we have a service called, or a set of services called SageMaker. It's a set of tools, a set of frameworks, a set of features and services that allow engineers and machine learning engineers and data scientists to build these pipelines to train models, easily train, deploy models without having to reinvent the wheel, but still use their own data and still tweak and tune their models. And finally, if you're a service or a startup like Deliveroo, who just wants to give added value to your customer, we have a whole number of managed services like recognition, textract, forecasts that allow you to do many of your bread and butter tasks like personalization, text or speech detection, sentiment analysis, image recognition, out of the box, right? So these are managed services. You don't need any machine learning experience. You can send your requests to a certain HTTP and API endpoint, and that endpoint will do the inference for you, right? In this case, Foodora used the recognition to filter out inappropriate images for their customer support team, right? So to recap, we have, if you're going to be building AI/ML for your startup, think of the rice cooker questions and think of the fighter jet questions, right? The rice cooker question is, don't over-engineer. For this, ask yourself, do I have enough data to warrant a more sophisticated model with more degrees of freedom, or should I just stick to something simple? Have I calculated the baseline? So have I tried something really simple, something naive, simple, just to see how it performs? Because sometimes that could surprise you. Simple if-then logic can be good enough. Finally, the fighter jet questions are around the OODA loop iteration, right? And the ability to iterate fast. And then ask yourself that, are you measuring the right things? Like, do you have business alignment with business stakeholders? Do you have business KPIs that you can point back to when you're having a discussion with your CFO or something like that, and you know what should be optimized? Do you measure model drift? Do you have processes in place that do CI/CD for you for machine learning? So this can be, again, SageMaker pipelines, or something like Airflow, or MLflow, Kubeflow with SageMaker are all options that help you orchestrate your machine learning service deployments. All right, so to get started, please visit our machine learning landing page, where you have lots of reference architectures, best practices, workshops, a whole bunch of Jupyter notebooks that you can try out, and read up on case studies to see how other startups are using machine learning on AWS to drive those KPIs that matter for your customers, right? All right. Thank you very much. That was me. You could feel free to reach out to me on either email or on LinkedIn. Please, I would really, really appreciate it if you would take a 1-minute survey to let us know how we're doing with these talks. It's really important for us. But aside from that, that was it. I will not be taking questions live right now, but I would love to talk to you on the conference floor about what you're building, your startup, even if it's not necessarily AI/ML. I'm part of the startup team for a reason, because I loved interacting with startups as a former entrepreneur myself. So thanks for being here, and looking forward to hearing from you. Please do the survey.